Okay, let's unpack this. Normally, when we do these deep dives, we start with something in the human world, a pattern, a conflict, a social problem, and then we trace it back to the natural world.
But today we're flipping that completely on its head.
We are. We're starting at the absolute bottom.
Right at the bottom. We're diving into one of the most fundamental, and honestly, one of the most mysterious puzzles in all of quantum physics.
And we're going to use that puzzle to shed some light on how our own world-human systems, social structures, actually works.
All through the lens of the universal law of increasing complexity, or ULIC. And the whole thing pivots on this really radical idea.
Which is that the universe is built, and I'm quoting from our source here, without an endpoint of rest.
It's a concept that just completely defies our common sense. I mean, everything we build, every system we know, an engine, an economy, it needs constant energy just to keep going.
And eventually it stops. Friction, entropy,
Yeah.
something gets in the way and the motion just winds down.
But at the smallest scales, that rule is it's completely
Wow.
violated all the time, without exception.
So let's frame this whole deep dive around that one big unanswered question. Why does subatomic motion never end? Even when you take away all the external energy, all the heat, all the light, all the force, what keeps it going?
Well, what's so fascinating here, just to start, is the sheer persistence of it all,
Right.
the cosmic memory of matter.
Tell us a bit about that timeline. What are we talking about?
I mean, think about the hydrogen in the water you're drinking right now.
Right.
Most of that matter was created in the first few minutes after the Big Bang. That's 13.8 billion years ago. And the heavier stuff, the carbon and oxygen in your body, that was forged inside stars that died long before our sun even existed.
So you have particles that are ancient, billions of years old, and then particles we can create right now.
Exactly. An unimaginable amount of history is stored in that matter. And yet, and this is the key, despite that colossal age gap, all their subatomic parts, the electrons, the quarks, they all behave identically.
So a particle from the dawn of time acts the same as one made in a lab today.
It has the exact same baseline energy, the same restless motion. It has this built-in refusal to just settle down and be still.
And that really is the paradox. If motion needs energy, and we know energy fades over time, stars cool, things slow down, how can this subatomic world keep moving with the same unwavering vigor?
It's like it has a motion pattern that was programmed in once, and it's completely independent of history or age.
It's a structural challenge. It forces us to look past just energy and into the very architecture of reality.
Right, because this motion is non-negotiable.
And this is where we shift from it being a mystery to it being a structural constraint. Physics shows us that total stillness isn't just difficult to achieve, it's actually impossible.
It is impossible. When you cool matter down toward absolute 0 to 0 Kelvin, you'd think the motion would stop. But it doesn't.
You hit a floor.
You hit a hard floor. It's called zero-point motion. Electrons keep fluctuating. Quantum fields, even in what we think of as an empty vacuum, they keep oscillating. It's this irreducible fundamental activity.
Okay, so if that's zero-point motion, what's the quantum mechanical reason? Why can't we just drain all the energy out?
Well, the reason is, it's very counterintuitive, but it's about the tension required for anything to hold together. It's governed by the uncertainty principle.
You can't know both a particle's position and its momentum with perfect accuracy at the same time.
Exactly. And if motion went to absolute 0, you'd know its momentum perfectly. It would be 0. And that would mean its position would have to be perfectly defined.
But you try to pin down an electron's position that precisely.
Then the uncertainty in its momentum becomes infinite. The particle would just instantly fly away from the nucleus.
So simply put, still particles can't form stable atoms.
Correct. Stability itself actually requires that constant, persistent wobble.
So physics describes how it works, gives us the math. It says, for matter to be coherent, motion must persist. But, and this is the boundary we keep hitting, it doesn't explain why.
It explains the consequences of the architecture.
But not the blueprint itself. It doesn't tell us why reality is built on a framework that just forbids stillness from the get-go.
And that distinction, the how versus the why, is so important when we start debunking some of the more intuitive answers people reach for.
Okay, let's do that. Let's start with the most romantic one. Myth number 1. This is all just a fading echo of the Big Bang.
That one fails pretty quickly. Because if it were just remnant energy like the cosmic microwave background, it would have cooled and weakened over 13.8 billion years.
Right, and we've already said that new particles have the same motion as old ones.
They do. The motion is intrinsic. It's not residual. It's not a leftover.
Okay, so it's not an echo. What about myth 2? That it's all tied to nuclear processes, the energy coming from stars.
Well, that's confusing cause and effect. Fusion explains energy exchange, how you convert one type of energy to another in a reaction.
It doesn't explain the baseline motion of an isolated particle sitting alone in the dark and cold.
Precisely. This motion is there in the total absence of any external process. It requires zero input.
And the third one, which I think is the trickiest, conservation of energy. If energy can't be created or destroyed, isn't that the answer? It just persists.
And our sources are so clear on this. Conservation is the ultimate accounting rule for the universe. It's a perfect statement that the total amount of energy is constant.
Good.
But it doesn't explain the architecture. It doesn't tell us why the lowest possible energy state, the absolute ground floor, has to contain motion instead of absolute rest.
It just tells you the total in the bank account stays the same, not why the account can never go to zero.
That's a great way to put it. We know the total is constant, but we don't know why that constant total demands active tension at its lowest point.
And this brings us right to the edge of what physics knows, the big, glaring problem of vacuum energy.
Right. So quantum field theory needs these fluctuations in empty space to work. The math requires them. But when you try to calculate how much energy density those fluctuations should create,
The number you get is just, it's wild, right?
it is arguably the biggest disagreement in all of modern science. The energy predicted by the theory is higher than what we actually measure from cosmology, by a factor of 10 to the power of 120.
A 1 with 120 zeros after it?
Yeah.
That's not just a small error.
No, that's a crisis. It shows you exactly where the description breaks down. Physics can describe the need for fluctuations, but when it tries to put a number on it, the math just shatters. We're missing a fundamental piece of the puzzle.
So we've established stillness is forbidden. We've established that the usual answers, even conservation of energy, don't explain the why. So if physics hits a wall here, where do we go?
This is the exact point where we pivot to the universal law of increasing complexity. The insight here is that this motion isn't a byproduct of energy. It's a structural necessity.
A necessity that comes from a condition that's even more fundamental than energy or force.
Correct. And that condition, in ULIC, is termed contradiction.
And we need to be really, really careful with that word. This isn't about conflict in the way we usually think about it.
Absolutely not. It's a technical term. It refers to an internal condition where the tendencies that are essential for a thing's existence can't be resolved into a single static state. They have to coexist.
Okay, so give us a concrete example of that at the quantum level.
Let's go back to the electron. Its existence depends on two demands that are, well, they're in opposition.
Okay.
It needs localization. It has to stay near the nucleus to form an atom. But it also requires uncertainty. Its momentum can't be zero, which means it can't be perfectly localized.
So the electron has to be both here and at the same time not perfectly here.
Exactly. There is no single fixed state of rest that can satisfy both of those demands at once. So the system can't settle down. It can't be still. The motion, that quantum wobble, is the physical expression of this unresolved structural tension.
So the motion isn't being caused by an external push. The motion is the solution, is the active compromise that holds the whole thing together.
It is the dynamic expression of unresolved requirements. If the tension could be resolved, the particle would be still, yes, but it would also dissolve. It couldn't exist as a coherent thing.
This persistence of motion, then, reflects a universe built on an architecture of asymmetry.
Yes. The idea is that the universe never existed in some state of perfect symmetrical balance. This foundational asymmetry is called change. And it's not a force, it's the primordial condition that makes forces and motion possible in the first place.
Wow. Okay, so the huge takeaway is that subatomic motion never stops because it's the most basic expression of a universe that requires active, unresolved tension just to hold its own shape.
Coherence is a dynamic process, not a static state.
And if you follow that logic, stillness becomes impossible at any scale, really.
It is. To be truly still, every single internal tendency would have to be resolved. And a state like that would have no distinctions, no tension, no form. It's structurally impossible.
So let's scale this up. Let's take this rule and apply it beyond the subatomic world. What about at the molecular level?
Well, the classical assumption is that if you cool a molecule down, the motion stops. But the quantum rules are still in play.
So even at absolute zero.
Even at absolute zero, a molecule still has 0-point vibrational and rotational motion. The chemical bond holding the atoms together is only stable because the tension between the forces of attraction and repulsion is active and unresolved.
The bond isn't like a static stick connecting two balls. It's a continuous negotiation.
It's a dynamic tension. If attraction won completely, the atoms would collapse into each other. If repulsion won, they'd fly apart. The bond, the structure, requires that active, non-zero contradiction.
And then we can go bigger again, to the cosmic scale.
It's the same logic. Think about the entire universe. Its stability depends on the ongoing tension between gravity, which is pulling everything together, and cosmic expansion, which is pushing it all apart.
If that tension resolved.
The universe as we know it would cease to exist. It would either collapse into a singularity or fly apart so fast that no structures could form. The coherence of our universe, with its galaxies and clusters, depends on that active, unresolved tension.
So motion, born from this structural contradiction, is the prerequisite for all complexity. Atoms, molecules, life,
Yeah.
even societies.
And that is the ultimate transfer of insight. If coherence at the microscopic level demands active tension, that logic gets carried all the way up.
This is the social warning that's hidden in the physics.
Mm.
If a stable atom needs irreducible motion to exist, what does that say about a stable society that tries to enforce stillness?
It says that social systems can't find long-term stability by trying to eliminate all their differences, their conflicts, their internal contradictions.
They're essentially trying to achieve absolute zero.
A state that is structurally forbidden. When societies try to freeze tension, often in the name of some perfect unity or harmony, they're not building stability, they're building brittleness.
Because just like matter, they decay.
Exactly. Real social vitality, real coherence, depends on having structures, institutions, laws, markets that are designed to channel movement. They have to let ideas, energy, and differences circulate.
And when you block that movement, when dissent is suppressed or economic flow is choked, the tension doesn't just vanish.
No, it accumulates. It builds up under the surface until the system distorts and eventually it fractures. The lesson from the quantum world is that vitality comes from structures that can hold active, unresolved contradictions, not from trying to create perfect, frictionless harmony.
This is really something. We started with a tiny electron that refuses to sit still, and we've ended up with a structural blueprint for how to build a resilient society.
We've gone from a deep physical mystery to a fundamental structural necessity.
That motion isn't a problem to be fixed or contained. It's the foundation of existence itself.
And the ultimate conclusion is that the stability we're all looking for isn't a destination. It's not a place of rest. It's a process of constant channeled movement, survival, emergence, complexity. It all depends on structures designed to manage active tension, not to suppress it.
So, if this endless motion reflects a fundamental asymmetry in the universe, a bias toward change that's been there since the very first moment, here's a final thought for you to take away.
Consider this. What kind of structural asymmetry in your own life, maybe in your routines or your own knowledge, is preventing you from finding rest, and is therefore the very thing driving your own capacity for transformation and growth?